Hello, students. Good day and happy asynchronous day. Today we're going to discuss about the quantum number. But before we proceed to the discussion, let us watch this video. If you know the rhyme or tune of this video, you can go and you can sing it. Alright. So it's nice to hear the motivation song for quantum number. So let us proceed to our discussion about the quantum number. So let us discuss and let us know what are the quantum numbers. So we have here a columns. We have now quantum numbers, symbols, possible values, and description of each quantum number. So in a quantum number, we have the principal quantum number, we have the azimuthal quantum number, the magnetic quantum number, and the spin quantum number. When we say the principal quantum number, the symbol of this is n, and the possible values of this is positive integers. Again, a positive integers, not a negative one. So n is equal to 1, 2, 3, 4, and so on and so forth. So for the description of this, describe the size and distance of electrons from the nucleus. It also indicates the energy of the electrons. The another quantum number is the azimuthal quantum number, or written in a cursive small letter L. Okay, the possible value of this is 0 to 1, 2, 3, 4, or 0 to -1, -2, -3, and so on and so forth. For the description of this, describe the shape of the orbitals. Value of sublevels are 0s, 1p, 2d, 3d, or it can be um, 2s, 6p, or whatever that you have in a column. All right, in our table of elements. So, magnetic quantum number, okay? The magnetic quantum number, the symbol of this is small letter m and a cursive sub description, which is the L or the cursive small letter L. So, it can be negative L to positive L, including zero. So describe the orientation on space of the orbital. So the next one is the spin quantum number, which written as small letter m, and we have a sub letter which is letter s. Okay, the possible values of this is positive one half or negative one half. It describes the direction of spin of the electron. All right, the second table, no, the second table is the quantum numbers, or we have here a description and value number or the valued number, and also the letter value. We have now the atomic orbital digestions and magnetic quantum number. And we have also the number of orbitals and number of electrons. So we need to study also the table of elements, because all of this is come from the value of every elements. All right. So we have the principal quantum number, which n. Okay. This is the raw of that written on the periodic table. Also, we have the value 0, 0, 0. Okay, we have in our table of elements, we have 0s to 2s, 3s, and so on and so on. It depends on the number of electrons of the elements. Okay, through it presented new ideas on how elements emits its line. X spectra Bohr's atomic model was rejected due to several reasons. What are the reasons? One is because it is not suitable for elements having more than one electron. Another factor was the discovery of the dual nature of electrons, where it is particle-like and wave-like at the same time. It can move in circular orbits because its move is wave-like. The next one is we have the Werner Heisenberg, also said according to his Heisenberg uncertainty principle that it is impossible to determine accurately at the same time both the position and velocity, or the momentum of a particle. The mere act of observing the electrons make it change in behavior, both position and momentum. So the location of electrons outside the nucleus is dependent on probability, not on how Bohr envisioned the exact location. His idea that electrons are quantized was still accepted. The solution to these problems came in when Erwin Schrödinger proposed the quantum mechanical model of the atoms. What you can see here in this figure. So, Niels Bohr only used the one quantum number in describing the location of electrons outside the nucleus, while Schrödinger model he added three more quantum numbers. So the quantum number describe how electrons are distributed around the nucleus of an atom. So this is the nucleus, and this is the electrons that surrounds in nucleus. All right. So the principal quantum number, azimuthal quantum number, and magnetic quantum number describe the probable location of the electron. The spin quantum number describe the behavior of the electron in its location. That is how it spin in its orbital. Just remember, the azimuthal and the magnetic describe the probable location of electron. Okay, and the spin quantum number describe the behavior one. Okay, the principal quantum number, we have the sub of n, describe the side the size of an electron orbital. The larger the value n, the larger the size of the orbital and its corresponding energy. It is called energy level or shells. All right. As you can see here in this figure, we have n is equal to 1, n is equal to 2. Okay. It depends to the energy level or of the shells given by the electrons. Okay, the azimuthal quantum number, aka angular momentum quantum number, or written in the sub of a cursive letter L, define the probability of finding an electron in different direction in space. That is the shape of the electron orbital. This is also called sublevel or subshell. The first three lethal values of the azimuthal quantum number describes the spectral lines of the sublevels. They represent S for sharp, P for principal, and D for the fuse. However, starting with letter F, fundamental, the sublevel are assigned with the succeeding letter G, H, I, and so on. So we have the magnetic quantum number, okay, or we have the M sub of letter L describes the orientation in space of orbitals. Its values corresponds to the number of orbitals in the sub level. So lastly, we have the spin quantum number or M sub with the letter S, small letter S, describe the direction of the actual spin of the electron. This will be the further discussed in next topics. So that's it. That's it. It's all about quantum number, and we have the continuous discussion next meeting. And I hope all the descriptions of every quantum numbers you've learned now, and see you on next meeting. So that's it for today. Goodbye and God bless you.